Good evening, ladies and gentlemen. Welcome back to the AstroCast Live. It's been a hot minute. This is, I think, the first episode we're doing in about a month's time, because of scheduling stuff, it hasn't worked out, and I've been tired from work, and I hadn't got a new work schedule and stuff like that. But we're here now, and we have one more episode, not counting this one, left in the second season. We do 14 episodes a season. I don't know why I decided on that number, but that's just kind of what we do. But anyway, I'm here with this guy. Let's see if I can switch it over to him. There he is.
What's up? What's up?
You might need to put that closer to yourself.
Hello, hello.
That's a little too close.
What's up?
You just got to watch the little level there and make sure you're not clipping.
Okay.
If it goes yellow, it means you're clipping. And if that's the case, then they're going to hear the.
Okay, got it.
Yeah, so.
Sounds good.
Let me switch it back to myself. So we're going to be talking about some interesting stuff tonight. We're going to be talking about some time travel, some black holes, maybe a little bit of relativistic physics. I like talking about relativistic physics. So yeah, physics, time travel, stuff like that. But you guys know what's coming. Before we get started, would you smash that like button? I'm kidding. No, I mean I'm not, but it what?
One hurts. It just hurt.
That's why I do it, because it's funny.
Hey, it's funny, yeah.
But anyway, we're here on YouTube live every Friday. It still says Mondays on there, but we're live every Friday at 8 p.m. Pacific Standard Time, plus or minus 15 minutes, by the way.
Friday's the new Monday. Let's get it.
Friday's the new Monday, and let's see. You can I'm rusty. I'm really rusty. You can find us on Spotify. And pretty much everywhere you find your podcasts, Apple Podcasts, Google Podcasts, Anchor, everywhere. And you can follow me on Instagram at joe.czall. Do you want to plug anything?
And hit me up on Instagram.
There you go.
j.morei. That's about it.
All right. I think I covered everything, right?
Yep, that's about it.
Something like that. If I didn't, oh well. So we're going to be talking about some time travel. Well, what do you want to start off talking about? We can start off talking about time travel, but I think we might need to lead into that with some relativity.
Okay.
What do you know about relativistic physics?
So, when it comes to relativistic physics, I pretty much only know like the basics, like, time is relative, speed is relative. If I'm moving 30 miles per hour and you're moving 35 miles per hour, to me it looks like you're just moving 5 miles per hour relative to me, but obviously relative to everyone else, 35 miles per hour. And
Kinda.
pretty much. Explain to me.
Kinda.
Enlighten me.
So, relativity is kind of tricky. It's once you wrap your head around it, it's not that tricky, but it's still kind of tricky. It's not very intuitive. And essentially, I've just realized I still had the camera on you. I'm a terrible producer. Matthew, I need you back. Matthew's in Mexico.
I know.
So, anyway. His current location is, and he's staying at this hotel.
Imagine. His IP address is this.
Just dox Matthew every time he comes here, every time we do a podcast. But anyway, relativity, we've talked about it on the show before. But essentially what it means is is exactly right what you're saying. Time is relative is one of the key aspects, and it's relative to the speed that the observer is going. For example, the faster you move, the slower time appears to travel for you to an outside observer. Meaning, if you were to take a spaceship, let's use the twin example. There's two twins born at exactly the same time, even though it's not physically possible, exactly the same time. So they are exactly the same age. One of them stays on Earth their whole life. One of them gets in a rocket ship and travels at the speed of light, if that was possible, just hypothetically. And then came back to Earth, hypothetically. His brother, or his twin on Earth, would have aged more than he had by the time he got back. Because time travels slower to an outside observer if you're moving faster. Now, this gets really, really tricky and complicated and convoluted when you bring in E equals mc squared. And what that means is the faster you travel, let me start over. There is a certain speed limit, and this is the speed of light. And at a certain point, if you are going fast enough, you cannot have mass in order to go that speed, and that's what the speed of light is. The speed of light, or light, physically has no mass, and so it can travel at the fastest possible speed, which is near instantaneous. And so at that point, time is irrelevant, which is really really cool, and that's what I wanted to talk about time travel with. So that's what kind of lead into it. So what are your thoughts on time travel? And
On time travel itself?
well, and that stuff.
So actually,
from a physical.
So something I was thinking about of relativistic speed in physics is, at one point I was thinking humanity has always wanted to reach distant stars and planets faster and faster.
Uh-huh.
But at what point does that become almost irrelevant? Because if we send a ship close to the speed of light to Pluto and back,
Uh-huh.
and it follows these physics, by the time they come back, it'll be maybe hundreds of years into our future, to the point where it might not even matter, according to that theory. So, in a way,
Not necessarily.
explain how. I'm curious.
So, just because, so let's say for the twin example, it's not like he takes 100 years and then comes back. It's like they all travel the same amount of time. Kinda. Like if there's no universal time, it's all relative. That's the tricky thing to come up with. So, for example, the twin that's on Earth. Let's say the total length of the trip from the observer on Earth is 3 days. You know, ballpark. 3 days, goes there and comes back. The guy on Earth, the twin on Earth, will still have aged more than the twin who left for 3 days. So it's not like, see, it's really tricky to wrap your head around because it's not intuitive. I like how my dog's just like walking around in here exploring. But anyway, I'm trying to think of a good way to explain it that's more intuitive, but I mean, it's just really not intuitive.
It's such a difficult concept because it makes sense, but it doesn't make sense.
Yeah.
So I see what you mean, but I'm also like, what?
Look at this dog. Don't pick her up, by the way. She's losing her winter coat.
I noticed.
She's just shedding all over the place. I would point one of the cameras down, but then I'd have to readjust them.
Just readjust the whole setup.
I'm trying to think of a good way to say this. It's not like, this is probably the better way to say it. It's not necessarily saying that if you were to go and come back from the speed of light, it would take longer for you, like physically, than if you were traveling at a slower speed. That's not what I'm saying. What I'm saying is, if you're traveling at or near the speed of light, then it will take, it's almost like the distance. I'm trying to think of a really good, of a good like way to say this, but I'm kind of struggling here. Because I know what I mean in my head.
Yeah.
And I'm just trying to communicate it to you. So, I had it for a second. It's almost like, it's just weird because time is not relative. Let's take the black hole example. When you fall into a black hole, to the outside observer, the person falling into the black hole will look like they are getting slower and slower and slower and slower and slower and slower and slower. To the I'm sorry, that's not at all right. To the outside observer, the person inside will look like he's going faster and faster and faster and faster. Inside. No, I said that wrong. It's the other way around again. The person on the inside, this is the way to say it. The person going into the black hole is going to be falling down into the black hole. As he accelerates faster and faster and faster, the outside world is going to also go faster and faster and faster relative to his time, because he is slowing down to the outside world. So yeah, I said it right the first time. I second guessed myself. So that's what I mean by time is relative.
That's such a messed up concept.
It is.
I'm just trying to picture from both ends.
Yeah.
You know, because
it's different.
One guy's going to see himself just falling quickly and losing sight of everyone, while the other guy will never see him truly disappear from sight if he's going slower and slower.
Yep.
So it's just such a strange concept.
So that also assumes that you can see inside of a black hole.
Which is,
You can't. He would just, So because light can't escape, the guy would just slowly fade away. He would literally look like a ghost was just vanishing, like just slowly, like the transparency was just going down, like if you were in Photoshop, you know. I'm serious. That's what it would look like, because the light would just get dimmer and dimmer and dimmer, and then eventually it wouldn't be there because it couldn't, reach outside the black hole. So, I forget what his name is. What's his name? I think his name is Sir Penrose, or it's Penrose. I think it is.
William Penrose, no?
I think yeah, Penrose. He's a physicist, and his whole thing is that he thinks consciousness is not computational, but that's not what I'm referencing in this. I was listening to a conversation with him and Jordan Peterson, and they were talking about an interesting concept of the end of the universe, and how Jordan Peterson brought up the fact that he thought that at the end of the universe, if theoretically it were to collapse in on itself, because that's one of the theories, that all of the black holes would just become one black hole. And so he thought, since to the observer that's inside the black hole, if time was slowing down for them and the universe was going faster and faster around them, then one black hole would not be distinguishable from every single black hole, because eventually it would all collapse into one black hole. So Penrose was like, no, you're wrong, like almost immediately. But I thought it was an interesting concept, but apparently it's not right. So what he brought up is what he thinks, what Penrose thinks would happen is, eventually we know for example, if everything does collapse in on itself and become one black hole, which it doesn't necessarily mean that, or isn't necessarily going to happen or be the case. It's just one of the theories. If that happens, a black hole eventually will be evaporated by Hawking radiation. And what that means is eventually all of the mass in the universe will become photons or light. And when that happens, this is where it ties back into time travel. And this is why I wanted to start with relativity. To a photon, time is irrelevant. There is no time. It is both at the beginning and the end of its journey at all times, which technically means also that space is irrelevant to a photon. It's technically everywhere, because, if it can't distinguish between being here and here, but it takes that path, then it is everywhere all at once along that path. And so if the whole universe is just all photons, then there is no time. There is just physical space. And he was saying, I forget how he connected it back to this, but he said that something along the lines of it is indistinguishable, that case, from being the end of the universe to being the beginning of the universe. And he thinks that's how the universe was essentially made, and where it's like this cycle. But it just got me thinking about photons, and I'll bring something up later about photons that I discovered. But anyway, I want to hear your thoughts on the end of the universe and time travel.
On the end of the universe itself. That's a big question. That's a loaded question.
That's a big question.
That's a very loaded question. So, assuming current calculations and current theories, the universe is still expanding.
Yep.
Right? And if we just take just a common, I guess, an explosion, which I guess, if you believe the Big Bang, that's what the universe is.
Mm-hmm.
To think that it would just eventually all go back together from an infinitely large explosion is just, I don't know. It's just
it's not necessarily infinitely large, though.
But we don't know how big it is. And
no, we don't. But it doesn't necessarily have to be infinite. The universe, the matter in the universe doesn't have to be infinite. It could be a lot, but I don't think it's infinite.
I feel like that's just bordering on the multiverse and all that. But
maybe. I don't like that theory.
Why? Actually, why?
Multiverse?
Yeah.
I don't like it. I just personally, the only reason is just because I have a bias towards I like our universe. I think this universe is the only universe. Oh, sorry.
Sorry, Mike
called out. It to me.
Mike called out a cutie. That's me. I'm sorry in the chat. Hey, Mike.
Oh, I haven't been reading.
Sorry, I haven't gone back to your text. I'm a terrible texter.
That's funny. Oh, it's still on me. Whoops.
Anyways, but what I was thinking about the other universe.
Uh-huh.
Quick thing, I want to answer your
Yeah,
question.
go for it.
I was thinking, so yes, that's a possible theory, but I was also thinking, what if it just keeps expanding forever? Because yes, the gravitational force will eventually slow it down. I do agree with that.
Maybe.
But what if it just expands so fast that it loses hold of itself? Because gravity has a range.
Yeah.
What if it just expands out of that range?
Well, actually, gravity, we know this from, again, relativity. Gravity takes precedent over long distances, whereas the electromagnetic spectrum takes precedence over short distances. And we know this because of, well, Newton's law of gravitation, which eventually was superseded by Einstein's relativity. And then electromagnetism is just Maxwell's equations, but they're kind of opposite. And so gravity doesn't necessarily have a range. The only thing that's dependent upon gravity is the amount of mass. And so essentially you could be right where the universe could potentially expand indefinitely, and gravity, there would be like rogue planets. Everything would be a rogue planet.
Rogue, yeah.
But to counter that, because if you think about the equation E equals mc squared, as you approach the speed of light, you cannot have enough mass, or you cannot have mass to go the speed of light. So my kind of thought process, and I know this is wrong, because I forget why this is wrong, but I know this is wrong, but my thought process, or like my intuitive thinking right now, is that if it accelerates to a certain point, it's going to reach the speed of light, and if it reaches the speed of light, it can't have mass because it's the speed of light. So therefore, everything will just be a photon, and you're back to the same conclusion. I know that's wrong. I don't exactly know why that's wrong, but I know that's wrong. But your thoughts?
I kind of like the way that sounds, though. It just
It
dissipates into light eventually in the end, but it's a very interesting thought.
Yeah.
Either way, the universe dissipates.
Yeah, I mean, that's a long time. It's a long time away.
Infinitely long, not even worth.
Yeah. Oh, not even worth. I mean,
but
it's fun to
it's
fun
fun
to
yeah,
talk
yeah,
about.
it's fun to talk about it, but
and it can help us understand some things that are relevant to us today, like the electromagnetic spectrum, gravitation. It's useful to study those things, the beginning and the end, because I mean, it's relevant to our studies today.
Kind of makes you think about. I know you don't like the multiverse theory.
I don't like it, but go for it.
I want to connect this to time travel because according to a lot of theories that I've heard, the first dimension, it's the x-axis. They say y-axis, and it. Okay,
oh, you're speaking my language.
Bear with me, yeah. And
you're
they
speaking
say
my language.
The z-axis is third dimension. We supposedly live in a third dimension, experiencing what they say is the fourth dimension, which is time.
Yep.
I don't know if I agree with that personally, because that is assuming time is spatial as opposed to.
It absolutely is.
That's
just as distance is relative. So space, time is relative.
But assuming that, if we took on some other form, that means we can just walk through it, like a space, and
forwards or backwards.
Yep. Exactly. Some new axis we can't even comprehend.
Yeah.
But we know is there. So, I don't really know where I was going with that, but I guess something I want to say is, the way I see it, if we're on that theory that time is spatial, I feel like a lot of paradoxes, for example, like there's always theory, if you meet yourself in the past, you'd be fine because...
Well, but the past wouldn't exist to you.
If you're traveling through time?
If you're traveling in the fourth dimension, your past would not exist in the third dimension.
Why so?
Because you are now in the fourth dimension.
But the future used in the fourth dimension. So wouldn't the past...
Well, so here's my point. This is why it's physically impossible. You cannot ascend dimensions.
Oh yeah.
I mean, that's not the reason why, but I don't believe you. I don't think you can.
At least not according to any.
At least not according to any modern theories. It's maybe possible. I'd have to think about that. But what you're thinking is, for example, hypothetically, if it were possible, we can talk through that. You start as a third dimensional being. Somehow along your timeline, you ascend into a fourth dimensional being, and then you decide what you're thinking is to walk back in time and change your life.
Okay.
Is that what you were saying?
Okay, I see what you mean. I'm picturing it like a road. Like you're a car on a road, and you want to go back.
Yeah.
But you're not there because you are okay. See, I feel like there's two ways of seeing this, kind of in a way.
No, I see how you're saying it.
Okay, bear with me here. Imagine we're moving through time, kind of like frames in a movie. Pictures, pictures, pictures. I feel like there's two ways of seeing it. The way I kind of would imagine it'd be cool is if we go back to a past frame where we're already there and visit that one.
Mm-hmm.
But the way you're seeing it is like a car on the road going back to a certain spot on the road, and it's not seeing another version of itself because it's the same car going back.
I don't know which way is right,
We don't know because yeah.
but I bet we could find out just by talking through it. I mean, it's not physically possible to do it anyway, so
Bet.
any answer we come up with will be right. It'll also be wrong because the premise is wrong, but
Some Schrodinger
anyway.
right there.
if our premise was right, we would be right. But our premise isn't right. Oh, I just realized it's not on me. Good job, Joe.
Just be shining.
It's just gonna be all you or all me for like 30-minute chunks. But no, it's an interesting concept because what I thought you were saying is like, because see, my whole thing is when you ascend to a higher, if it were possible to ascend to a higher dimension above the third dimension, you couldn't then just walk along the timeline, as another dimension and then change things in your past life in the third dimension because you are no longer third dimensional. It would no longer look like it does to us. It would look very different.
I see. What
For
you
example, to someone in a two-dimensional world, you can only see in 2 dimensions, but us in 3 dimensions, we can see inside 2 dimensions. Basically, if you have a box, just, standard box in 2 dimensions, you can see inside of that box. To a 2-dimensional being, you could not see, past those walls, right?
Mm-hmm.
Same thing for us. I can't see what's in the cube right in front of me. But a 4th-dimensional being could see what is inside that cube. And the reason is because of time. To us, time is the 4th dimension. To them, it would be a spatial dimension where they could see inside the cube. It's really wacky to think about.
It is,
and
yeah.
I really like that you brought this up because I wanted to bring this up. I discovered the other day. You might have to stall for me. I might have to go get my notes from my room because this got me really excited. I discovered the other day that the speed of light is not constant within every single dimension. It is a different speed from the 1st dimension to the 2nd dimension to the 3rd dimension and so on and so forth.
What's the trend it follows?
Well, think about it. If you're moving in 1 dimension, well, actually, if you're moving in 0 dimensions, you're a photon. Because the start is the end. There is no time. There is no space. 0 dimension is a photon. 1 dimension, you are moving the fastest physically possible you can, or as physically possible as you can, because it's a straight line. That's the fastest path. In whatever dimension you're in. The straight line's the fastest path. Now, if you add a 2nd dimension, you're now moving diagonally, or, whatever direction. But you're no longer going in a straight line. So from a 1-dimensional perspective, you are going slower. If you're viewing it like here, let's do it that way. If this is our 1st dimension, we're moving along in that line. That way, there we go. The fastest way to go is the only way to go, straight. If we add a 2nd dimension, coming out at the camera like that, and the photon is moving diagonally, the camera can't necessarily see the photon moving in a 2nd dimension, but it does see that it's moving slower in the dimension that it can see. You get my drift?
I see what you mean, yeah.
So, it is the fastest in a 1st dimensional only universe. Or in a frame of reference that is 1 dimension. In 2 dimensions, it's a little slower. 3 dimensions, it's a little slower. 4 dimensions, it's slower. And it slows. And I would be really interested to find by what function it defines, or by what function the speed of light changes in different dimensions. Because it would be really interesting to find out what the limit, as the number of dimensions approaches infinity, what that limit is. Can the speed of light be 0? And I suppose at the 0th dimension, there is no time and there is no space, so it can be 0. So that's really trippy, and I'm glad you brought that up.
I feel like this kind of goes hand in hand with relativistic physics too, because you said as you speed up, time slows down.
Yeah.
I feel like for a 4th dimensional being who can walk through time at a slower, faster rate, they're kind of already there in a way, because
Well, so that's the
We just
tricky
go through
thing
it.
because to a fourth dimensional being, they wouldn't consider time time. They would consider it a spatial dimension. And so it's almost like you couldn't really interact with a third dimensional being in the same way that we would picture interacting with each other, you know? Um, I don't know that we would be able to comprehend a fourth dimensional being other than in the passage of time. So maybe in a sense we're all fourth dimensional beings. We're just
Only going forward.
See, that's really weird though, because to us it's the passage of time. But like could you imagine I'm trying to imagine having a limited well no, actually that makes sense. You know, spatial dimensions can't be infinite, and our time here on Earth is not infinite. You catch my drift kind of?
Mhm.
I just realized the camera's still on you.
You gave me a limelight. Also, shout out Mike says just build a time machine. I'm all
Just
for
build a
that.
time
I'm all
machine.
for that.
Okay, so let's talk about this. How do we build a time machine?
Oh my gosh. Okay. Cartoon theory says get a crystal, a time crystal, and just plug it into like a blender. You know. Okay.
Okay.
But actually speaking, to be able to go into a next dimension using, let's say, to be able to go into a fourth dimension using third dimensional technology, is like, I don't even know how to.
Trying to ride a bike without wheels?
Yeah, yeah, pretty much. It's like trying to swim with an iron vest. You know, it just you just
Gotcha.
you'd have to have so much energy. Is the only thing I can really say, that it just, I guess in a way, punches a hole through this dimension into who knows what else. Just so much energy, it distorts our very space. In a way.
So here's my thought. There is no such thing as time. It's just a spatial dimension. Therefore, there's no such thing as traveling through time. Time is, in a way, finite because spatial dimensions have to be finite for a physical object, not for the universe. Technically, I think you could have a coordinate plane that is infinite. You know, there's no mathematical disconnect there or discontinuity there, but I don't know that you can have an object you can mathematically. You can have an object that has infinite spatial dimensions. I'm not sure that you can have that physically in real life. There might be a few objects that have an infinite surface area and a finite volume, or vice versa. I forget. I know you can do it mathematically. I'm not sure about real life. Someone might have to fact check me on that.
I've seen it's like a fourth dimensional object, almost like a tesseract or something like that.
Well, yeah. Well, the Tesseract's a whole different story. That's a fourth dimensional cube, basically, is all it is. It's essentially
Yeah.
what it is, and all it means is that the cube is growing. I mean, that's the only way we can view it, is that the cube's small and then it's just growing and growing and getting bigger and bigger. This stuff's tough to think about and
It is.
discuss because it's just so convoluted. But it's really fun to
It's
talk
like we're
about.
both right and wrong at the same time, you know?
Yeah,
it just
I don't know
makes-
that you really can be right. We're definitely
We're
wrong.
just both catastrophically wrong. Mike says buy a DeLorean. I think that's about as close as we're going to get, you know?
I was watching this YouTube video, I forget from who, and they were saying if you could theoretically make a cylinder of infinite length and then rotated it, then you could travel backwards in time somehow. I gotta find that video because that concept just seemed really weird.
That
me.
sounds weird. It seems like they're
I mean,
getting
obviously you
shapes.
can't have a cylinder of infinite length.
Yeah, it would just be infinitely wide. Or
Tall. Infinite length,
Oh, yeah. Oh,
Yeah.
length, yeah.
not radius. Or I guess height, you know.
Okay, yeah. That.
Yeah, it's just tricky. I don't know. Because, see, the whole concept of traveling in time is kind of very Hollywood-esque. And it's
Yeah.
it's very human because we perceive the passage of time as linear, whereas it's not really linear. It's more happening. It's not, well, that's not the right word. It is. That's probably the best way to describe it. You know, what's happening right now is reality. There is no past. There is no future. It is right now. That's the only, thing that exists. The future doesn't exist yet. The past doesn't exist. Hasn't existed ever. Just this is the only moment that exists right now. And just because time is relative to other people doesn't mean that we are all present in this physical universe right now. There's a concept of now, but there's not a universal concept of time. And it's kind of tricky. Like, how can you have a universal concept of happening, but you can't have a universal concept of time? Well, it's because ultimately it ties back to everything's just photons, in my opinion. This is probably wrong, but everything is one particle, and that one particle just got more energy from something and interacts with different dimensions. And based on what dimensions it interacts with depends on what type of particle it's going to be, how it interacts with other particles, and so on and so forth. But essentially, the reason there is only right now, there's only happening, there is only is because the zeroth dimension ultimately is all there was, and all there will be, and all there will continue to be. Because, I mean, from nothing we were born, and to nothing you shall return. Or from dust you were made, and to dust you shall return.
Now that's just getting to like the afterlife and everything else. That is a can of worms, to say the least.
I like to talk about that stuff on,
I've noticed.
on the podcast.
I've noticed.
What are your thoughts?
On that? On just
on
that,
everything. The whole shebang.
That is honestly like a existential crisis kind of statement.
Not really.
No, sarcastically, of course. Like,
okay.
I'm not having a crisis.
Gotcha.
Just the fact that what you're saying is just only now exists.
Well, yeah.
And there's nothing behind us. In a way, it kind of makes you think like our universe or this moment is kind of like an isolated just moment in a void of
literally 2 seconds ago, never happened, never existed.
Exactly.
It's only now.
And kind of just, I don't know, something I just kind of thought of while you were talking is, it's like we don't pass through time. I feel like more like time passes through us and affects us in a way. I know, because
that's an interesting
because
concept.
saying that we pass through time is assuming that we can pass through it and we're aware of it. But it's more like time ages things. Time is making this very moment pass. The cells on your body grow and die.
So I guess in a way, time is just the universe, and the universe is just God.
It's just this thing that's, you can't touch it, you can't hold it, don't even know it's there. Yet you know it's there, and you just kind of experience.
Just sounds like God.
It's something you experience.
Yeah.
Not something you.
Yeah.
Yeah. It's weird.
Yeah.
It's
yeah,
weird.
man.
Yeah.
This is a good conversation. I'm glad we're having this conversation. It's tricky to talk about this stuff, but it's so fun.
It really is. And something I kind of want to say,
Go for it.
I always found this so weird because the first dimension, okay, this might sound super ignorant or super intellectual, who knows? So, obviously, the first, second, and third dimensions are spatial.
Yep.
Because,
Oh, I see where you're going.
Why is the fourth dimension suddenly something? Let's say there's a first dimensional being. It's second dimensional being.
I can explain this.
Please do, because I've always wondered this.
Yeah.
It's a little flat dude. His name is Bob, okay? He lives in XY. He's infinitely flat, yet he could be tall and wide. And he, I'm assuming, could experience time as well.
Yep.
Because time, but why? But
I can explain this.
Why is the third dimension spatial as well? But why is time suddenly just this extreme concept?
So,
it's abstract.
Well, back to your two-dimensional example. How do we get from the second dimension to the third dimension? Actually, how do we get from the 0th dimension to the first dimension? The 0th dimension, there is no space, there is no time, there's just one point. This point is everything. What happens if you flick the point? Well, now you get a line. What is flicking a point? Well, you give it speed, right? What is speed? Well, it's a distance over a time. So you didn't have a distance, so you just basically added time to the equation. Not like adding like a mathematical operator, but like you entered time into the equation. And now because you added time, well, now you have a dimension, a spatial dimension. So now you're in the first dimension. Well, you have a line. What happens if you flick the line? Well, what is flicking the line? Again, adding some more time. And what happens when you flick the line? Well, you get a plane. And, I mean, what is a plane? It's a two-dimensional object. It's technically infinite, but it doesn't have to be. Let's see. What happens when you flick a plane? Well, you get a cube. And what is flicking a plane? Well, it's just adding time into the equation. So to each lower dimension, the next dimension up is time for that dimension. That's why the speed of light is not constant in every single dimension, because time is different in every single dimension. Time for the first dimension is the second dimension. So as you move in the first dimension, you physically are creating a secondary dimension. And that dimension is time. And the only reason it exists is because you are moving. And that just has to do with rates.
So I have another question then.
I just realized I had the camera on you the entire time.
It just knows me today. Okay, so assuming this theory, right, that looks the fourth dimension to us is time. So what would the fifth dimension be to us? I know, it might be impossible to explain, but what do you say?
No. I'm really glad you're bringing this up, because this is the thing that I'm trying to prove. I've been working on this for a while, and I'm trying to prove that every single interaction that we perceive is just a product of particles interacting with dimensions, whatever number that of dimension that may be. Now, the first dimension, we know, well, the first three, let's start with the first three. Well, the 0th dimension is energy, just pure energy. First, second, third, spatial. Fourth is time. This is all from a third dimensional perspective. Well, 5th, 6th, 7th, 8th, what the hell would those be? Well, if you think about it, if you're just adding time, well then maybe you get time squared, or like double time, or so maybe that would be some kind of flux, I'm thinking. No, but flux has to do with area, so maybe not flux. That's not the right word. What I want to prove, my hypothesis is, those higher dimensions are going to be able to explain things like the electromagnetic spectrum. Let's see. The weak force, the strong force. Different makeup of particles is just interacting with other dimensions. That's my theory.
Kind of makes you think of something. It's going to sound crazy abstract. But what if these proposed fifth dimensional... Okay, so the fourth dimensional being... Okay, let's bring it to here. Me and you, we can walk across the room. It takes time, right?
Yeah,
so
that's creating the fourth dimension.
The fourth dimension can be at both those moments at the same time. So this is just...
Not necessarily.
It can travel throughout those time dimensions, right?
Not necessarily.
Okay, bear with me, right?
Okay.
Fourth dimension is time. Okay. What if, just crazy insane theory, the fifth dimension is spatial again, obviously spatial like the rest of the theories, but can be anywhere at any time. Not like Schrodinger, but anywhere of their choosing. Like they could just travel through our physical space instantly, kind of just completely bypassing time, because to them it's just an inferior dimension. You know what I mean? Like from here to the nearest star instantly. Because to them it's just an inferior dimension that they live in.
See, it's tricky when you start to interact between dimensions. And for this, I kind of want to go to this. The only example we have, or the way that we could figure this out, is if we see the interaction that we have with the second dimension. So I think the concept that's getting mixed up here is time, obviously. And because what is time in the second dimension? Well, it's our dimension. So it's not like we can travel in time in the second dimension. I mean, we can, and we do all the time, just by existing. But it's not necessarily time travel for the second dimension. And the reason I say this is because, let's take a second dimensional being in a plane, a plane, or just a Cartesian plane. X and Y. There we go. That way, right there. You just have a little guy walking along here. Now, if the little guy is walking along, he is creating the third dimension. So we would see him walking along. Or I mean, he could even walk in this direction, and then that'd be. I mean, no, I'm sorry. That's wrong. I'm trying to. No, that he could, because technically the coordinate system, Cartesian, it moves along with you. It's all relative. So yeah, if you flick the plane, that creates the third dimension. So I suppose it's tricky. You know what it'll be? Stop motion animations. That's what that. So, like a 2D, like an old school like animation, like when you would hand draw them, like old school Disney ones. They drew it frame by frame, right?
Yeah.
And you would start frame by frame by frame, and I guess in a sense, because you could see every frame, you could see the start, you could see the beginning, and you could see the start and the end all at the same time. But you couldn't necessarily travel through time in the second dimension. You see what I'm trying to say? I bet you we could do an experiment with this, where we could try to set up a two-dimensional situation in real life in our third-dimensional world, and then try to see if we could travel through that two-dimensional space, but in our third dimension, somehow affecting time in the second. I bet you there's an experiment we could do with that.
Yeah, it's just strange, because if you see it like little frames, that kind of goes back to what I said about how they might see us as kind of frames, slides in the movie.
Yeah.
What if, as a third dimensional being, like, what if you just pick it out? You know, this is just a weird. Like, they would, I guess, travel through time through the assistance of a higher dimensional being, I guess, because they would pick them out of that frame, place them back somewhere else, and be like, hey, here you go.
So this is another question. Can conscious beings interact physically with other dimensions? I don't know if they can.
I feel like it'd be just impossible to comprehend.
Well, even lower dimensions.
Yeah.
Like, we can comprehend the second and the first dimension.
But they can't comprehend us.
Well, they can't comprehend us, but I'm trying to say we can't, like, move. You know, we can't devolve to the second dimension either.
Yeah.
You know, we can't really interact with a second dimensional being. There is no such thing as a second dimensional being. We live in a third dimensional universe. But I suppose if you walk in a straight line, you're technically moving in one dimension. But you're still existing in a three-dimensional world.
Wide, you still, you know.
Yeah,
tall.
you still have physical dimensions. So,
You'd
I
have
don't
to
know.
be infinitely skinny for that, so that's bad for the health.
It's tricky, man. It's tricky.
It is. It's just weird to think about.
It is. Yeah.
It'd be interesting. Like, everyone talks about moving up dimensions, and no one talks about moving down.
Well, that's I don't know. That might be just as hard.
Yeah, I dare say, and I dare say it might be more dangerous, because what if you can't move back from that second dimension? You know.
It's just weird because I think people have a concept of, you know, the dimensions as like ascending and descending is more like, you know, you need a lot of energy to do this, but like in actuality, like just by walking and just by existing happening right now, we are creating the fourth dimension just because there's movement going on. The particles in our body are moving. Everything is moving, and because everything's moving, it's creating time, and time is the fourth dimension to us. And so I think the only thing that can actually travel through dimensions is either one of two things. It's either particles, fundamental particle or elementary particles, or just photons. And I'm kind of leaning towards photons because I think photons ultimately make up every single fundamental particle, and we just see them differently because they interact with different dimensions. But I'm probably wrong about that. So that's why I'm kind of...
It's back and forth.
It's back and forth. What do you think about that?
That just gets so abstract, because then you get things like strings and brains and
Yeah.
all sorts of tiny particles that are just so small that people have barely even discovered
Yeah.
them in the first place.
So I think... I think when elementary particles come together, I think they can no longer travel through dimensions or like switch between what dimensions they operate in. I think once they coalesce, they're stuck in that dimension. And unless they get broken apart back into their elementary states, then I suppose they could ascend or descend on a physical dimension, maybe. Just because that would change their interactability with other things. And I guess, I don't know if certain amounts of energy, this might be something to look into. If certain amounts of energy can change a fundamental particle into another fundamental particle. Or if all of those fundamental particles were set at the beginning of the universe, because that would change on how, you know what I'm saying?
Yeah. So something kind of made me think about. So let's say a photon, right? You said it's everywhere, nowhere at the same time.
Yep.
So assuming that it's in all dimensions
Mm-hmm.
at the same time, right? So
Okay.
bear with me. So let's picture a sun shining light and photons
Okay.
onto our solar system.
Okay.
So assuming that, we can assume that this very light is existing in all the dimensions. And in a way, they're kind of on top of each other because the photon is in the same position, but in different dimensions. So in one dimension, it might be in a one-dimensional universe, second, third, like ours. But it's going to be in the same exact spot through multiple dimensions. So I guess that kind of makes it almost seem like...
Well, you can't be in the same spot and also be in different dimensions.
How come?
Because the same spot doesn't exist across dimensions. There is no universal constant dimension. And ultimately, I think the misnomer there is that photons are in all dimensions. I think photons are the 0th dimension, meaning everywhere instantaneity. You know, the only thing they have is a frequency. And if you kind of step through it, the 0th dimension, the only thing it can be is frequency, 1 over time. After that, you can add a spatial dimension, or actually, I should say you can add a time dimension, which then creates a spatial dimension to us from our perspective, and then you get, distance over time, and then you add time, and you get 2 distances over time, and then you add time again, you get 3 distances over time. I mean, but this is the cool thing too, and this is part of my hypothesis that I'm working on. You could also have a distance over 2 times, or a distance over 3 times, or a distance over 4 times. And that's the same as saying, a distance over 2 times is also the same as saying 2 distances over 1 time. So that's technically the same dimension, but interacts in a different way.
Mm-hmm.
For example, we have acceleration in the 3rd dimensional universe. And, acceleration is distance over time squared. So you got 2 times there. And essentially what that means is that our time... this is kind of E equals mc squared. This isn't really acceleration, but E equals mc squared. As you move faster, time is relative. So I guess you could maybe derive that from the acceleration equation there, just intuitively. Not necessarily, but essentially what I'm trying to say is that when you move from the 1st dimension to the 2nd dimension, you're adding time. But what if somehow you could preserve that time and say, now you have a speed, and you're not moving to the 2nd dimension? Well, that's what we see in the 3rd dimension all the time. We see, my hand has a speed moving right here, has some velocity, and I'm not moving into the 4th dimension. I am creating the 4th dimension with my hand. My hand, physically moving from here to here, that's the 4th dimension. Time. And so we preserve that time, pretty much. We don't go into the 4th dimension. So that would mean 3 units of distance, or not 3 units, sorry. 3 different spatial dimensions over 1 dimension of time. But that's also equal to 4 spatial dimensions. It's also equal to two spatial dimensions over two time dimensions. And I'll prove it to you. If you're not bored yet.
Oh, please continue. No, you go ahead, continue.
If you have the second dimension, you have a plane, or a square. How about a square? If you flick the square that way, and then flick the square that way, essentially, just adding here. That wasn't a good way to say it. If you flick the square, you get a cube. If you flick the cube, there's the fourth dimension. Well, flicking the cube is just adding time. So, if we add time to the square, we theoretically would get a cube. But let's say we hang on to that time. Well, now it's just a square moving in the second dimension. Okay. Well, what happens when we then add some more time? Well, does that mean then that we're suddenly in the third dimension and we're also moving? Or does that mean that maybe the square is accelerating? I don't know. But that's what I'm trying to figure out. It's a tricky question.
That is a truly.
And I just realized the camera was on you the entire time again.
Nice. They were just watching me just go like this and just stare. Yeah.
Yep.
The whole time.
So that was pretty fun.
That is just such a brutal concept to even begin to try and understand.
It's crazy, man.
It is insane. Yeah.
It's crazy.
You literally cannot comprehend it, but you can try. That's the fun part.
But the cool thing is you can mathematically figure it out, though. That's a cool thing.
That is cool, yeah.
So I just realized the camera was on you that whole time, too.
It's just, it's not auto shift?
No. I shift it myself.
Nice.
That's why I suck at it. Oh, let me switch it to me while you yawn.
I'm sorry, that was just an intense conversation. I'm just so like, wow, you know.
That was a good conversation.
It was very, you know, okay, it's totally different topic.
Go for it.
But I was reading this book on immunology the other day.
Okay.
Because that's what I do.
Okay.
When I'm bored, believe it or not.
Okay.
And I was reading this about proteins in a cell.
Mm-hmm.
And according to that book, the proteins are so small. It's at such a small scale in the cell that at that point water is significantly more thick in a way because the proteins almost directly bump into the water molecules themselves because they're both that small. But that seemed weird to me. It didn't make any sense because if we're assuming that proteins are made of amino acids are made of, you know, CAGT. CAGT is made out of elements, right? Or eventually it's made of, everything's made out of elements.
Yeah.
Why would a full-size protein be bumping into water molecules when water's already a very small... It just seems weird to me, you know? To think that a protein... It's
because of the electron clouds.
Yeah, a full protein is bumping into water molecules. First of all, if you're the size of a protein, what would the water molecules themselves look like? Would it look like globs of water? You know, it was weird. Would you see the angled bonds between the hydrogen and oxygen?
Yeah,
would
I wonder
see
if
the
they
atoms?
look more like crystals.
Yeah, would they look like atoms? Would they look like crystalline structures? What would they look like? And why are the proteins interacting as a whole protein and not just as a massive molecule bumping into the water itself too? Why? It just seems weird to me. Just such a weird concept. That at that
well,
scale.
yeah, we're not that small. It's hard to comprehend that.
Yeah, exactly. It's like trying to comprehend time. Just trying to comprehend something so small.
I honestly feel like something small is maybe more easy. Is easier.
More easier.
More easy. It's easier than trying to comprehend time as a spatial dimension. Because one is in a completely different dimension, but changing your size, you're still in the third dimension, I suppose.
Arguably, yeah, that's true. But at the same time, it's like when you're that small, is time even if you're like the size of an atom, is time even relative again?
So that goes back to what I was saying about maybe elementary particles can just swap between different dimensions because they're so small.
Yeah, that's.
But only if they're elementary particles, because if they're any bigger, then they coalesce and they get stuck.
Even an atom arguably is 3D because the electron cloud is 3-dimensional.
Well, the atom itself, the mass that it has is 3-dimensional.
It's 3-dimensional, yeah.
Just like we are. I mean, like, you know, my finger is 3-dimensional. It's got an X, a Y, and a Z.
Yeah.
But even if I like cut my finger off, it still is 3-dimensional. If I cut that bit of my finger off in half, then it's still 3-dimensional. If I keep cutting in half until I get to the atom level, it's still 3-dimensional. You can't get rid of the dimensions unless you get so small that you're at the quantum level. And and then you're not really playing by different rules, but the rules. See, this is the whole thing about quantum theory. It's not that the rules are different than they are up here. It's just that they're more relevant down there because everything's smaller and they're more fundamental. Whereas everything's coalesced up here, everything's more generalized. You know, all that stuff kind of, in my mind, all that stuff will kind of eventually like cancel itself out, and unless, you know, something combines in a way that makes it, you know, enter into our ballpark. But I don't know, it's tricky.
And another thing is when you get so big, I feel like the same rules apply. Time just doesn't matter. In a way, I don't know, because it just seems like if
I guess, yeah, black hole.
So massive that you are the creator of time distortions like a black hole.
Yeah.
Time is also irrelevant to you because
it's not so much irrelevant, but maybe that, I don't know. That'd be something interesting to look into. How time differs to the actual black hole.
Because we always pay attention to micro and atomic physics, but no one really talks about the macro as much, you know?
Well, we talk about macro a whole lot, but I think people have the naivety of thinking we've already figured it all out.
Yeah. It doesn't have the fancy ring of quantum
Yeah,
physics.
Maybe. But I tell you what, black holes are really interesting because they trap light. Light has no mass. The warping of space-time is so steep that light cannot physically escape on any path of trajectory. Now that's really interesting because what did we already discuss about photons? Is that they are everywhere all at once. So does that mean eventually every single photon will be inside of a black hole? I mean, maybe not necessarily.
Because I feel like they're being not produced, but I guess converted by stars, and it's just a cycle of recycling. Well, then again, that brings another question. There's a theory that black holes lead to something called white holes, or eventually.
Yep.
So
Einstein-Rosenbridge.
Exactly.
Yep.
So it won't really all. For example, a theory about the end of the universe being just one massive black hole. What about the white holes being produced by the black holes?
Well, so then there's another theory that's saying, well, there's two sides of this theory. One's the multiverse side, and one's the non-multiverse side. The multiverse side says eventually everything's going to collapse into one black hole, and then that black hole, actually there's two parts of the multiverse side, I just forgot. Everything collapses into one black hole, creates a white hole in a new universe, and creates a new Big Bang. The other side of that, for the multiverse part, is every single black hole, there's a white hole on the other side in some other new multiverse, and that's the Big Bang of that multiverse. Then there's the other side of that saying that all of the black holes coalesce into one white hole, and then that white hole is just our Big Bang at the beginning of our time.
That is quite the handful, yeah.
So, I don't think any of those are right, by the way.
Because you don't like the multiverse theory?
No, because I think there's more physical evidence to saying that white holes actually exist within our universe. There's I think there's only one instance of I think it's a gamma ray burst that couldn't be explained by anything that is theorized to be a white hole. Theorized. It's never been proven. But I think that's closer to reality as it could be a possibility rather than we can't even have anything to physically tell, experimentally. So that's just the way I lean. I also don't like the multiverse, so I'm probably biased.
Honestly, I'm a big fan of the multiverse theory.
I don't like it.
It just seems cool to me, I also saw Doctor Strange in the Multiverse Madness, not sponsored. Yeah. Saw it today, it just seems really cool.
Did you really see it today?
I really did see it today, yeah. And, literally, 2 hours ago. So, it's fresh in my mind. So, it just seems, the very concept is just cool. I mean, you can't deny that there's infinite versions of you, yet there's infinite universes that don't have you at the same time. Just infinitely different things. And those are just, I don't know, it just seems interesting. Just different dimensions. And those are all three-dimensional as well, in a sense. So we can also assume there's many universes for all the dimensions. It's just weird.
So then that begs the question, is there a universe that all those multiverses are living in? There has to be.
So a bigger universe.
Otherwise, huh?
Go ahead, sorry.
No, go for it.
So you're saying a bigger universe holding the other universes?
Well, it has to be. They can't exist independently, otherwise they would be the only, you know?
What if they're overlapping on different planes of existence?
The freaking conjunction of the spheres from The Witcher? Really?
Yes.
Oh, I haven't heard that argument ever, I don't think. Um, that's an interesting concept
Just on
I haven't
different
heard of, or I haven't
frequencies from
thought
our,
of.
yeah, just on different frequencies from our reality. Kind of like I kind of want to see like a ghost. And it's, bear with me. This is an analogy. Like let's say I don't care if you believe in ghosts, you don't believe in ghosts. Let's say you see a ghost. You can't touch it. Maybe you see it, you know it's there, but you cannot interact with it. Maybe that's how the universes overlap on top of each other in just different planes and realities.
See, I think that's better explained by dimensions. I think it's better explained that maybe saying, my whole thing is, in a multiverse, God would also have to be multi-present in all of those multiverses.
Omnipresent, just
Omnipresent in all of those multiverses. My whole thing is, the way that that God has been described to me is, He is who is. He is the universe. He is also the king of the universe. Like, He is everything and all at once, all the time. And the thing with the thing that I think is better than the multiverse is dimensions. I think that when you go up and down in different dimensions into dimensional shells, I think that's a better explanation for why things happen and how things happen than a multiverse. And I don't know, I feel like it's a little more consistent. The thing that really gets me with the multiverse isn't that it's infinite. Infinity isn't a real hard concept for me to grasp personally. I think the thing is that there's different universes than this. I think what's more likely, or what I would like to think is more likely, is that it's not necessarily there are more universes, but that there are different things within our universe. That probably didn't make any sense.
Continue. Explain more. Like, what do you mean by that?
I might have to think on this.
Okay, one more thing. Something interesting made me think about. So, I'm gonna tie this to fate. In a sense.
Go for it.
Let's say we can view a second dimension. You mentioned earlier. You said you see like slides, like pictures,
Mm-hmm.
right? Bob is walking in his two-dimensional world to his two-dimensional wife. Okay, would you see? You would see his future, but would you see one specific future, or would you see his branching realities for different choices that could potentially be made? And that begs the question: is there fate? Because would there be only one path? For one path that can only.
So that's
can only
almost
be
a
taken?
free will argument.
Yeah. Or what if in just every reality for that guy, he only takes that specific path because that is just what is meant to happen, but it is his choice.
See, I think I know the answer to this. I'm probably wrong, and I probably won't explain it well.
Love it. Love it.
So just like normal. I just realized I'm slouching. See, the thing is, the only way we can really interact with the second dimension is by creating a drawing. That's really the only way we can interact with the second dimension. And even then, it's not really the second dimension, because even if you have like a crayon on a paper, it's still the third dimension. It's just really, really flat, you know? A piece of paper still has a third dimension. It's just really thin. So I don't know that we can really interact with the second dimension in a way that is meaningful enough to be able to answer that question. Now, as it pertains to free will, there is one way that is going to happen, but it is not yet determined. And the reason for that is the only one way that's going to happen is right now. Or I should say, happening is the universe right now. That is the only thing that's real. And the end, in a way, is determined, but also not determined at the same time, because it doesn't exist yet. It doesn't exist ever until it reaches now, but it's never going to reach now because now is now and now can't change. If that makes any sense.
Now it's happening. Now it didn't happen. You know what I mean? Yeah.
I mean, there is only now. That is the only thing that's real. That's the only thing we can comprehend. We can't comprehend the past. We have memories, but that ultimately, that is just our rendition of now, or I'm sorry, that's our rendition of the past now. That is ultimately our own simulation that we are simulating now in our brains. You know, who's to say that past even actually happened, and it's not just, you know, our neurons in our brains making it all up because we have dreams, you know? It is impossible and imperceptible, or it is impossible to tell if something truly happened. It is also impossible to tell if something truly will happen. And that is because we're not omniscient. We're not omnipresent. We're not omnipotent. But I think, to tie it into faith, I think God, who is everywhere all at once all the time, in all things, is all things, I think to him, everything has already happened. There is no now for him. There is just being. And I think that's a difference. I think there's a difference between saying there is only now and there is only being. Because ultimately, God is everything that exists ever, all the time, everywhere, all at once. And that's a really hard concept to grasp. That's infinite.
Insane concept. So what you're saying is, for my religious and non-religious people, catering to everyone here. So God, right?
Yep.
Sees everything, is everything in a way.
I don't know that we can say see, or because I don't know that he sees.
I guess
in the
is
way we
everything,
think.
right? So he sees everything. Okay.
More like is everything.
Is everything, right?
Is within
So,
everything.
Would this everything be alternating different timelines for people? Because how would this affect people, right? Are you saying people only have one destined timeline?
No.
Or do they have branching timelines?
But there is no branching either. Neither is true. There is no end. There is only now. What you choose to do right now will affect your future in a sense of how we view time as linear. But what you do right now is ultimately the only thing that is real, the only thing that exists ever, is what we do right now. And go for it.
Do you believe in fate, though? Something predetermined?
Absolutely. I don't believe in something predetermined. I think
not predetermined, almost like meant to happen.
Yes. To get religious, I think God wants the best, or wants all of us to be the best versions of ourselves. And ultimately that means living a good and spiritual and faithful life. And to be with and for others. And when you do that, that's how you get fulfilled. That's the only way to get fulfilled, in my view, is to be on the quest for the religious quest for meaning. I think that is the only way to be fulfilled, the struggle of the human experience. But bringing back to more physics and physical and that kind of stuff, and not so much philosophy, I think it's just a misnomer, or I don't know if that's the right word. I think it's a misconception that there is a future and there is a past, because that's how we view time as people. There is only now. When we die, that might change. But right now, there is only now, and this is the only thing that exists ever. It doesn't mean you throw your life away because nothing ever exists and nothing matters. It absolutely matters what you do right now, because now is all there is, and that's why it matters, because it's so important. But I don't know, I think it's a misconception, like I was saying, that time is linear, and that something has happened and then something will happen in the future. I think it's a good tool as humans for us to use to catalog history and to kind of communicate, but I don't think it's correct in a physical sense.
That's just quite the statement. But I will say that. I know. I just like to believe sometimes in just supernatural things. You know, just
Mhm.
there's just so many things that can't be explained, like
Oh, absolutely.
just uncanny coincidences to from everyday things like that to just the grand scheme of the universe itself. Like, let's say the universe is created by some bomb, an explosion, right?
Okay.
Big Bang for all the
Mhm.
scientists out there. What are the odds that that explosion somehow created your dog,
Yeah.
right?
Or anything.
Anything
that
at all,
matter.
or literally something as advanced as a particle accelerator from a bomb,
Yeah.
which is what it
But
was.
it's not necessarily a bomb,
Well,
but I get what you're saying.
I'm just
I
making
get what you're
literally
saying.
what it is, just a big fat explosion, right?
Yeah.
I don't know. I just like to believe that there's. I'm not particularly religious. I'm spiritual. That call me a hippie. I don't know, but
You
I just
damn
like to believe
hippie.
that there's something at play too. You know, not just
Uh-huh.
pure physics
Oh,
that
absolutely not.
creates something.
No,
you
I
know?
agree with you.
Hippie.
And I
I'm just
think
kidding.
that thing is ultimately love. And I know it's gonna sound cheesy.
Oh my gosh. Okay, go ahead. This sounds like okay. Sorry, quick thing. This
Yeah.
definitely sounds like one of those movies, like the way you just said, like those movies.
It
where
sounds
they're
like Interstellar.
wow,
I'm
the way
sure.
to beat that monster is through love. Oh my gosh.
No,
okay.
not in that sense.
Ah, messy. Okay, go ahead.
But ultimately, that's the thing that binds us and ultimately everything together, is our relationship with that thing. And what is love? Well, it's willing the good of the other and desiring to be in relationship with the other. And I mean, if all we can be defined by is our relationship with others, then the only thing that connects us is love. And what is love? Well, love is God, essentially. God, or I should say more, God is love. Faith, hope, and love were some good things he gave us, and the greatest was love. I forget where that's from, but it's in the Bible. Yeah.
That's shout out Clone Trooper 2.0. What's up? I know you're in Mexico. What's the vibes? What's up, Jessica?
You joined at the perfect time. We're talking about God and the theory of everything. Oh, I just realized the camera's on
He's
you
gonna
again.
hear this in like 20 minutes because the delay is just
Oh, probably.
yeah, you know how it goes. But
But man, it's tricky. But ultimately, the best description I have for God is what he says to Moses in Exodus. I am who am. Or, in layman's terms, God is that is. He is everything everywhere all at once. And he is the thing that binds us together, and ultimately the creator. It has to be the creator of everything, not in the sense of like we drawing it out or molding it physically, but the universe in a sense created itself, because the universe is God, but not necessarily the universe is God, but more God is the universe. You get what I mean?
that's kind of what my philosophy in life is. I think God and the universe are synonymous in a way, and
Oh yeah, definitely.
yeah, so that's kind of how I see it. And I see what you mean. Yeah, I feel like that's what's kind of at play. It's like not necessarily something physical, but something that's just there,
Yeah.
something you can feel. But who knows?
Yeah.
Until you respawn, I don't know. Who knows?
Respawn. Well, that's another question. At the end of your life, what happens?
I personally want to believe. This is gonna sound super crazy. I want to believe that your consciousness gets sent, or just you kind of become one with the universe and you just experience a reality that you want to experience, and where you go to like your own good place, your
Okay.
own version. That's just kind of what I want to believe, because as a third dimensional being, I can only think so much, and that's just I just want to believe you go to the greatest version of whatever you think paradise is.
I don't agree with that.
What's your version?
I don't necessarily know it's my version. I want to talk about this first. This isn't what my version is, but I know that there's people who are fond of thinking of reincarnation.
Ah,
And my thought of reincarnation is, where you like passed into a
Yeah.
new body, but the same consciousness. My whole thing with that is that means there's only ever one person, and that there is only one consciousness, and that consciousness is passed from person to person forever and ever and ever until the end of time. That's my take on. Oh, I just realized the camera's on you. That's my take on that.
there's actually a YouTube video by Kurzgesagt. I know you've seen Kurzgesagt before. He has a story just like
yes,
that.
yeah.
He has
yeah.
a video called The Egg.
Mhm.
And the whole story is about that. It's one consciousness that's being passed down through every human in all of history through all of time. And every time he dies, he meets the creator of the egg. And every time he's like, when you live through every life, you will be born as one of us.
Okay.
And I don't know, it kind of reminds
Huh.
me of that.
Okay.
Interesting concept. I don't
That is an
believe it,
interesting
but
concept.
very interesting concept.
My take on that, though, heaven is not. I can't pretend to know what heaven is. But heaven is not angels and clouds and perfect, good all the time, everywhere. Because, and this is something that I think a lot of atheists get wrong of their perception of heaven, where they say, well, heaven can't exist because you say it's eternal happiness and eternal bliss. Well, that would get boring after a while. And I think it's a misnomer that that's what heaven is. Because ultimately, if you are with your creator, who is your creator that you would be with? Well, you are with the universe. You are one with the universe. It's almost like it's not necessarily being in a perfect place. But it's more being in a state of love. And I don't mean by that like romantic love. I mean like God. And by God, I mean the universe. So, and essentially, you are in a state of perpetual everything. In a sense, you become like God, but not necessarily like God. You kind of get what I'm saying?
I see what you mean, yeah.
But it's definitely not anything that we think of, and it's not going to be. We will not be able to perceive it in the way that we are perceiving things right now.
Oh, yeah.
At all. I know that for certain. Now, I don't even know that we will be able to see or hear or taste or smell in the afterlife. Who knows? I do know that, at least according to the Catholic faith, which is, I'm Catholic, that the body is intrinsically attached to the soul. And so there is an essence of the body that is spiritual and that will be resurrected and joined in the afterlife somehow. What that means, I have no idea. And I'm not going to pretend to know. But it's interesting to think about. But I don't think it's anything like anyone imagines, like out of Hollywood. So, yeah.
Well said. That is trippy. That is just...
I don't know about that. I think
all these are just such strange and abstract concepts. But
Oh,
I love
yeah.
them. I love them.
Yeah, me too.
Yeah,
Yeah.
it would really get boring. It was just eternal happiness. Like, I think that's kind of makes life interesting, you know? The sucky parts.
Well, that is the human experience.
It is.
You cannot physically get fulfillment without struggle and suffering. You cannot get fulfillment if you have everything you could ever want all the time. What purpose is there? You have no purpose. The only purpose you could have is pleasure. And if you're constantly having pleasure, well, that would get boring. And you would develop no purpose. The only way to derive purpose is the religious the religious quest for meaning, which is the human experience, which is to struggle. You cannot have purpose any other way. And I think when I say that, people don't quite understand what I mean. Because I've said that before, and people have said, well, I'm not religious and I have purpose. Well, that's not what I'm trying to say. I'm not trying to say the religious experience is something you have to go to church to get. The religious experience is intrinsic to the human experience. And what that means is we as a species have always been religious and will forever continue to be religious. Or if you would like, spiritual, or, however you want to say it. Not necessarily organized religion. But we have always had this concept of wonder and awe of the divine beyond what we can comprehend. In a sense, music is very, very religious. It's a very intrinsic religious experience for us. I mean, you can see that when you go to concerts and raves and like stuff like that. It's an intensely religious experience, and not in the sense of like you're going to church and but it's an intense feeling of fulfillment because you are surrounded by everyone else and you are deep in like earth, or that's not the word. Almost like enveloped in the music. You almost all become one thing, and I mean that is the religious experience, the quest for meaning, and through music, we've been able to find meaning in collective struggling, I guess, is a good way to put it.
It really is.
Um,
I feel like it gives
Yeah.
voice to the things that can't be explained, in a sense. Music.
well, and music is. I mean, I'm not even gonna get to that. I'll
As
talk
a
to you. I'll talk to
musician,
you about that later.
As a musician, I can talk about this for days.
Okay, well, we'll save that for. We'll save this for another podcast.
Oh yeah.
Because I have a lot to talk about music, because music is really just frequencies, and frequencies is innate to our universe. Like, that's what the zero dimension is a frequency, and that's all there is, pretty much, is frequency. And but
That's a whole.
that's a whole
yeah.
nother can of worms that we don't want to get into.
Oh yeah.
But it's just, we as a species have always been religious. We've always, and what I mean by that, we've always needed a purpose. And that purpose has to be beyond us, whether that's raising a family, or serving a divine purpose, or helping other people, or being with and for others, or, I mean, anything like that. But all those things are to struggle and to suffer. And you cannot have purpose without the religious quest for meaning. And that is what it means to be human. We are on a constant quest for meaning. And I think that might be where we end it.
Nice.
I don't know if I've actually said that on the podcast before.
You just kind of say bye, head out, or what?
No, I mean
Oh,
the whole spiel
the
that I
whole-
just said.
Yeah, I hadn't heard that before. That's new.
But that's something that I've thought about a lot and very deeply. And this is one thing that I do think I'm right. But anyway, any last thoughts?
that was solid.
You like
That was-
speechless
I'm
after
just
after
like
my
thinking about that myself. You know.
Yeah.
I just want to believe fate is real.
fate?
I need it on my side this week.
Yeah.
That was it. Got some plans. Anyways. Go
Oh,
ahead.
brother. No, talking about fate just real quick. There is a plan. It's not in the sense of someone
It's like writing
of
a
you're
notebook.
predestined to do something, but there is a plan, and that plan is unfolded through our relationships with others and our quest for meaning. And yeah, I mean, ultimately the plan is the universe, and the universe is God, and not necessarily the universe is God, but God is the universe. And but anyway, thank you guys so much for watching.
Boop.
We went a little bit over time, and by a little bit I mean about 45 minutes.
Nice.
Eh.
Nice. Amazing.
So, before we end it, I want to find the right button. Here it is. Make sure you guys, if you enjoyed what you listened to here, give us a thumbs up. Little like button there, at the bottom by YouTube. Hit the bell so you can get notifications, so you don't miss another episode
Subscribe.
of the AstroCast Live. Yeah, subscribe if you like what you see here. And you can find us pretty much everywhere you find your podcasts. The AstroCast Live is live every Friday at 8 p.m. You can follow me at joe.seesall on Instagram, and anything you would like to shout out, Jair.
You can find me at j.morei at Instagram.
All right.
Thank you.
And with that, I think we're going to sign off for the night and maybe have a end of the podcast discussion about some random things, and then
Post podcast.
yeah, post podcast podcast. All right, guys, thanks for hanging out. We'll see you next time. Let me see if I can figure
Ciao.
out how